Hello, I'm Jeong from Asan Medical Center. In this video, I will present our study titled Team Learning-Based Bone Age Assessment for Predicting Final Adult Type in Girls with Central Precocious Puberty. Central Precocious puberty is defined as the premature activation of hypothalamic-pituitary gonadal axis, leading to early development of secondary sexual characteristics. This condition is significantly more common in girls, and its incidence has been annually increasing in Korea. The most important clinical consequence of central precocious puberty is reduced final adult height, which results from early epiphyseal closure. This can negatively affect patients' mental health and self-esteem. Therefore, preserving final adult height is the primary goal of treatment. Bone age is a key parameter for evaluating growth potential. The GP method is commonly used, but it has limitations, including dependence on reader experience and inter-observer variability. Recently, deep learning-based models have been developed for bone age estimations. These models provide reliable bone age estimation and improved efficiency. However, studies evaluating AI-based bone age for height prediction in central precocious puberty remains limited. Several bone age-based height prediction methods are used in clinical practice. Among them, the Bailey-Pinel method is the most widely used one. However, since it was developed on Caucasian population about 17 years ago, the Korean growth chart-based method has been introduced as an alternative for Korean children. Therefore, the purpose of this study was, first, to assess the accuracy of predicting final adult height in Korean girls with central precocious puberty, using AI-derived bone age assessments integrated into prediction models, and second, to investigate key factors associated with final adult height in this population. This was a retrospective single-center study including patients diagnosed with central precocious puberty between 2000 and 2022. We included female patients who completed GnRH agonist treatment and had available predicted adult height and final adult height data. Patients without the height data were excluded. Patients were evaluated at multiple time points, but we analyzed data at two key time points, treatment initiation and treatment completion. We collected height, weight, and height percentile. Mid-parental height was also calculated at baseline. Bone age was assessed using three methods based on the GP atlas. First, human GP. Bone age was assessed by an experienced pediatric endocrinologist using the GP atlas without AI assistance. Second, AI GP. Bone age was defined as the most probable age among the GP atlas standards, as suggested by the AI software. Lastly, AI GP weight. Bone age estimated by the AI model using a probability-weighted average of all GP atlas standards. We used PunoMed bone age software for AI-based prediction. Let me show you how the patient's bone age was assessed using the AI software. The images on the right side are standard GP atlas images. It shows the probability of each standard. The atlas with the highest probability is selected as the most likely bone age, AI GP, similar to how a human would make the assessment. The AI GP weight is then automatically calculated by summing all GP atlas-based bone ages, each weighted by their probability. Let's move on to the height prediction models we used. First, in the PP method, patients are classified into one of three categories based on the discrepancy between their chronological and bone ages. Next, according to the identified category and bone age, the percentile of adult height achieved is obtained from the BP table. And finally, the percentile and current height is incorporated into the formula to predict the adult height. In the KGC method, we calculate the height score corresponding to the patient's bone age using the modified LMS method, and we project the patient's position to age 18. This reflects the growth pattern of Korean children. By combining three bone age methods, two prediction models, and two time points, we obtain 12 predicted adult heights per patient. Out of 1,254 patients who met the inclusion criteria, 1,132 patients were excluded based on predefined criteria. Consequently, 122 female patients were included in the final analysis. The mean age of the included patients was 8.3 years at treatment initiation and 11.0 years at treatment completion. The mean final adult height was approximately 160 centimeters. At the treatment initiation, the predicted adult height showed high RMSE with low R-square values. By the treatment completion, RMSE values were lower, while the R-square values were higher, indicating a trend toward improved predictive performance. In addition, the concordance correlation coefficients were also higher at the end of treatment, indicating better agreement between predicted and final adult heights. Between the two height prediction models, BP method gives superior height estimates compared to the KDC model. Among methods, AI-GP BP at the treatment completion showed the best performance, but differences were not statistically significant among predicted other types. These are the blend data plots showing the difference between predicted other type and final other type. The blend data plots at the treatment initiation revealed a limited agreement of 8 to 7 centimeters for mean differences from each method. The blend data plots at the treatment completion showed narrower limit of agreement of 5 to 7 centimeters for mean differences for each method. At treatment initiation, significant predictors of final adult height were mid-parental height, high percentile score, and AI-GP weight BP. At treatment completion, only high percentile score and AI-GP weight BP remain significant predictors. So, in our study, human-based and AI-based methods showed comparable performance in predicting final adult height. AI-GP weight BP showed the highest explanatory power, but there was no statistical superiority. This should be interpreted as trends rather than definitive differences. Clinically significant predictors of final adult heights were the following. The predicted adult heights based on the BP method showed a higher R-square value, higher concordance, and narrower limit of agreement than the KGC method. This trend may be attributed to the BP method's advantage in reflecting individual growth tempos. Also, BP method slightly overestimated final adult height, while KGC method slightly underestimated it, which may reflect ethnic differences in the baseline population. Prediction accuracy improved after treatment, but even the best performing model still showed an error range of 5 cm. This poses some limits on how precisely we can rely on these predictions in actual clinical practice. This suggests we need further refinement and calibration of these models. We also observed a notable shift in the predictors of final adult height. At the start of treatment, mid-parental height, high percentile score, and AI-GP weight BP were independent predictors. However, by the time treatment was completed, mid-parental height was no longer a major factor, and AI-GP weight BP became an even stronger predictor. This shift likely reflects the effect of treatment on growth trajectory. These are some limitations of our study. First, it is a single-center retrospective study with a relatively small number of female patients. Also, we could not evaluate all available bone age assessment methods and height prediction models. Finally, other factors that could potentially influence final adult height could not be included in the analysis. In summary, AI-based bone age assessment demonstrated comparable performance to human experts, and the BP method showed relatively better agreement than the KGC method. Predicted adult heights were independent predictors of final adult height at the initiation and completion of treatment. These findings support the clinical utility of AI-based bone age assessment for predicting final adult height in girls with central precocious puberty. Thank you very much.